All right, let's dive into one of the most mind-bending ideas in all of science. And we're going to use the incredible film Interstellar as our guide. So get ready because what we're about to explore might just completely warp your understanding of reality itself. You know, the entire plot of Interstellar really hangs on this one seemingly impossible question. The astronauts land on a planet where time moves so slowly that a single hour for them means 7 whole years have passed for everyone they left behind. I mean, come on, how could that possibly be real? Okay, so let's set the scene. You've got the crew of the Endurance on this desperate, last-ditch mission to find a new home for humanity. Their journey takes them through a wormhole to a system orbiting a massive black hole they've named Gargantua. And their very first stop is this strange water world, Miller's Planet. Now, you might be thinking, okay, that's just some convenient Hollywood magic, right? A cool plot device. But here's the wild part. This incredible time stretching, this idea that 1 hour could equal 7 years is actually predicted by one of the most important scientific theories ever developed. So who's the genius who figured all this out? Well, of course, it was Albert Einstein. His theory of general relativity completely flipped our understanding of the universe on its head. But to really get what he did, we have to rewind a bit and look at how people thought about the universe before him. For hundreds of years, going all the way back to Isaac Newton, we basically thought of space as a giant empty box, a fixed, unchanging, three-dimensional stage where all the events of the universe just sort of played out. And time? Well, we saw time the same way. We pictured this giant, invisible clock for the entire universe, just ticking forward at the exact same rate for everybody, everywhere, no matter what. It was a constant, and it was totally separate from space. Simple, right? Well, this is where Einstein comes in and just changes the game completely. He realized that space and time are not separate things at all. He said they're fundamentally linked, woven together into a single dynamic four-dimensional fabric that he called spacetime. It's not the stage, it's the very fabric of reality itself. Okay, so if reality is this giant fabric, the next obvious question is, can you mess with it? Can you bend it or stretch it or warp it? And Einstein's answer was a huge, resounding yes. And the thing that does the warping is gravity. And this is the part that changes everything. Einstein completely reimagined gravity. It's not some weird invisible force that pulls things together. Instead, big, massive objects tell this space-time fabric how to curve, and in turn, that curve in the fabric tells other objects how to move. Probably the easiest way to wrap your head around this is the good old trampoline analogy. So first picture space-time as this giant, perfectly flat trampoline. Now take a heavy bowling ball, let's say that's a star or a planet, and place it right in the middle. What happens? The fabric sinks down, right? It creates this big curve. Now, if you roll a little marble nearby, it's not being pulled by the bowling ball, it's just following the curve in the fabric that the bowling ball made. That curve is gravity. And right here, this is where your brain might start to melt a little. Because remember, space and time are the same fabric. So when gravity warps space, it has to warp time too. The stronger the gravity, meaning the deeper that curve in the trampoline, the slower time itself actually moves. So now that we have that incredible piece of the puzzle, we can jump right back to Interstellar and finally solve that central mystery. Let's see how this all clicks into place. So the astronauts, they spend just a few hours on the surface of Miller's Planet. But when they get back to their ship, the Endurance, which was waiting for them in a safer orbit, get this, 23 years have gone by. It's a staggering difference, but it's exactly what Einstein's equations predict.
So why the huge difference? Well, it's because Miller's Planet is orbiting dangerously close to Gargantua. A supermassive black hole is like the heaviest bowling ball you could ever possibly imagine on that trampoline. Its gravity is so immense it creates an extreme curve in space-time, causing time for anyone nearby to slow down to an absolute crawl compared to the rest of the universe. 1 hour can actually equal 7 years.
Now, I know this all sounds like crazy far-out science fiction, and it's amazing in movies, but here's the thing. General relativity isn't just a theory. It has very real consequences that affect technology you probably use every single day. That's right. This effect of gravity on time, it's called gravitational time dilation, is a real measurable fact. And if our engineers didn't account for it, some of our most critical modern technology would just completely fail. And you want to know the perfect example? It's probably in your pocket right now.
Your phone's GPS. The satellites that make your maps work are orbiting way up high, where Earth's gravity is just a little bit weaker. Because of that, the clocks on those satellites actually run a tiny bit faster than our clocks do down here on the ground. We're talking a difference of only about 38 microseconds a day. That sounds like nothing, right? But if engineers didn't constantly correct for that tiny, tiny difference, your GPS location would be off by about 10 kilometers every single day.
Which really leaves us with this one big, fascinating question to chew on. Interstellar uses Einstein's real science to show us that time, something we all experience as a constant forward march, is actually flexible. It really makes you stop and think, doesn't it? If one of the most fundamental rules of our reality can be stretched and bent, what other laws of the universe might not be quite as solid as we think they are?